the profile insertion attacks. There are some factors. So we need to differentiate another differentiation factor between attacks. So where is the focus of the attack? Only on particular users and items. So if the attacks target a user, it will be different with the attacks target on items. Targeting a subset of items or users might be less suspicious. So if you have a very specific target like this one, you cannot detect the attack because it is very specific. That's why it is less suspicious. More focused attacks may be more effective. So once you know, okay, I want to target of the new smartphone, okay, then it will be more effective. So attack profile more precisely defined. Why I explain this one? Of course, I do not want you to be attackers. Please do not be attackers. But we need to know why the attackers define this one. And we need to find out how the AI can work to understand the attackers. If we are the AI engineer, or if we are the ML engineer, the machine learning engineer, we need to know how the attackers do. So we need to classify the criteria for the recommender system attacks. Usually, the attackers, they will think about the cost. How costly is it to make an attack? If they want to attack, it means they need to insert the profiles. So, how many profiles they need to insert? And then, is knowledge about the rating metric required? The easy one is just giving the rating. But maybe there might be some other things. For example, content. Should we consider the content? Or should we consider the knowledge? Okay. We already learned about the content base. We already learned about the knowledge base. Or, yeah, it can be more informative with the context. Those kind of knowledge, so some of the content or the knowledge or the context, sometimes it is not in the public, but it can be estimated. So if you are very good at the machine learning, if you're very good at the AI, you can estimate the knowledge. And because this recommender system is already popular, you can easily design the algorithm. So is the attack designed for a particular recommendation algorithm? You know the nearest neighbor algorithm. If the new attackers is very expert on the machine learning, then they will easily make the attack. So that's why a good company or a high level company, they should not use the very easy algorithm. They should make a complex algorithm because of this one. Detectability. How easy is it to detect the attack? So if you can understand easily the attack, then the attackers cannot do his work. So that's why this kind of things you need to understand how we can prevent, how we can avoid the attackers, how we can check the attackers to make it as a good AI. So there are some types of attack that we can learn. The first is based on knowledge. If the attackers do not require any knowledge, or we call it low knowledge. Low knowledge means, the attackers, they do not need the content. They do not need the product knowledge. They just give random rating. Okay. So it means just giving rating. All the ratings is 5, 5, 5, 5, 5. So it is easy. We can understand that, okay, this is attackers. But if the attackers have a high knowledge, then we need to be careful. So this is what we will learn. Random attack. Random attack is an attack assigned to the filler items IF by random rating. So random, just give 5 or 4 or 3, 1, 2, random. So this attack requires little knowledge or no knowledge, especially since the overall rating means in many systems can be easily calculated. So if you know in website there are many information about the ratings, you can easily check, okay, what is the rating of restaurants? Okay, it is 5, or the rating is 4.3. Then you can easily get that one. It means you can easily calculate the means. Okay? You can easily calculate the average and so on. So this kind of model attack, you can use push or nuke attacks by giving random, and then can be random for the high rating or random for the low rating. So this is the general scheme for an attack profile. We have the item. Okay. Some items already been selected. Why they already have selected this item? Because maybe this is the popular items. So they select the existing items, and then they can put the filler. Filler means, they put something in these missing items. They can put something on this no available ratings, and it can influence the target. And they can keep the unrated items. Maybe the unrated item is not that popular, so nobody gives the rating. Then they will just keep it as unrated. Now, the important thing is here. How they fill this item based on the selected items to do something on the target item. Attack models mainly differ in the way the profile sections are filled. So if you want to fill in the filler items, you may have some different case of the attack. If you use the filler items based on the selected items, then you can also have another things. Okay? So we will learn one by one. Random attack, as I mentioned to you, it takes random values for filler items. So here, we just give random values. So, typically, distribution of rating is known. For example, for the movie domain, yeah, if we know that the average is 3.6 and then the standard deviation is around 1.1, then you can easily make random rating between the value. The idea of this random attack, it is to generate profile with typical ratings. So they are considered as neighbors to many other real profiles. So in this pillar, they will use the average. So, the normal distribution. Then they will give rating based on the normal distribution, and on the target, they will give high or low rating. So if they want to give high ratings, then it means all the attackers will give 5, like what we saw before. If they want to give the low rating, then all the target will have 1. Actually, this is limited effect compared with more advanced models. Maybe from the algorithm point of view, this will affect, but nowadays, the high level companies, they do not use the collaborative, so they can easily look at the random attack. Average attack. So the average attack means the use of individual items rating average for the filler items. The individual's item rating average. So intuitively, there should be more neighbors. If you still remember the NN, the nearest neighbor. If we set equals to 1, it means 1 neighbors. And based on some research, the best nearest neighbors on the movie, they put 20. It means when they want to attack some kind of items, if it is related to movie, then they can make 20 different nearest neighbors. There will be additional costs. The additional cost is to find out the average rating of an item. So if user 1, I would like to know the average of user 1 on item 1. I have user 2, I want to know what is the average of the user 2 on the item 1 for all the ratings. And so they said that using this average, it is more effective than the random attack. Especially if we deal with the user-based collaborative filtering. But additional knowledge is required, because if it is only based on the user, then we don't have any information about the user profile. We do not have any information about the item profiles. So we need more knowledge. It is quite easy to determine average rating values per item. Values explicitly provided when item is displayed. So if it is only about this average, it's not that complicated. There is another kind of attack, we call it bandwagon. So this bandwagon, it exploits additional information about the community ratings. So usually they have the community, for example, fan, like the BTS, okay, the very popular boy band, very popular girl band. They have the community. So the community, they will give always good ratings. So the bandwagon attack, they try to get those ratings and then apply to the items. So the simple idea is add profiles that contain high rating for blockbusters. You know, blockbusters. Usually we call this blockbuster is for the high popular movies or some more interesting movies. Okay. So add the profiles that contain the high rating for blockbuster in the selected items and use random values for the filler items. Now, we have the selected items and then filler items. So for the selected items, we select the top movies. And then for the filler items, we can just make it random. That's what they call as the bandwagon. Intuitively, it will lead to more neighbors because popular items will have many ratings. Of course, if you watch the movie, if many people watch that movie, of course, they will put ratings and we will utilize that rating. And rating values are more similar to many other user profiles because it is blockbuster, so many people give rating on that movies. So, for example, injecting a profile with high rating values for the Harry Potter. Okay. So people who like Harry Potter will give the high rating. So the attackers will give also a high rating for Harry Potter. So the algorithm will think that the attackers is the real. And what happened? After they are similar with the blockbuster like the Harry Potter, they can attack. Maybe they will give the low rating. They can give the high ratings. They call this is low cost. Because they can just set the top selling items on blockbusters can be easily determined. So we know which item is very popular, which item is the top, and does not require additional knowledge about the min items rating. There's another attack. We call it segment attack. It is a designing an attack that aims to push item A. So we want to push a new product, or maybe it's not a new, but it's old, but nobody gave rating. So I want to push the item A. And then find the items that are similar to the target item. Then I would like to make some kind of content-based similarity. So these items probably liked by the same group of people. And then we can identify a subset of user community that is interested in the item similar to it. And the next, we can inject the profiles. Inject the profile means we will insert the profiles and high ratings for fantasy novels and random or low ratings for other genres. So this is based on the content. If we know the user profile, we can just give a good ratings on some good profiles, and then we will use low rating for different profiles. So this item will be pushed within the relevant community. It means if they already have the community, then this information will go to that community and the community will inform to other people. For example, push the new Harry Potter book. So we know that there are many Harry Potter books before, and then we want to push the new Harry Potter. Then the way is the attacker will inject profile with positive rating for other popular fantasy books. And the Harry Potter book will be recommended to the typical fantasy book reader. So this kind of segment attack is also possible. But we need some more knowledge. For example, what is the genre of the book? So based on the content base. Mix. In the mix, it means it's very special. Special, it can be special noob or special push. But people usually use the special noob because this kind of mix, they want to attack to decrease the rating. If it is about love or hate attacks, the target item is given the minimum value. So target will be 1 for the rating, and then the filler items are given the highest possible rating value. So the target item is low, but the filler items will be higher. It gives serious effect on the system recommendation when goal is to nuke an item. So another way around, push an item is not effective. So that's why we call it this is love or hate attack. In this case, they love it, but on the target, they hate it. Another kind of attacks, they have the reverse bandwagon. The reverse bandwagon means the associate target item with other items that are disliked by many people. So they try to find, for example, I have one target. They want to find the item which has been disliked. If the person disliked this item, then we put also the low rating, 1, 2, 1, 2. And then we put also the low rating on the target. Then it will decrease the rating. Selected item set is filled with minimum ratings. So this is the selected items is filled with the low rating. Popular tag. So popular tag, it requires more knowledge about the rating database to set the ratings of filler items. So it is similar to bandwagon attacks. So bandwagon, maybe the other word is popular attack. AOP attack. What is it? Average over popular, or this is the AOP items. So it is simple and effective strategy to obfuscate the average attack. Do you know the word this one? Obfuscate. With the issue word with to blur to make it not obvious. We cannot also distinguish, okay, or to make it confused. So the average over popular, it tried to confuse the attack, whether it is high or low. So the AOP X% attacks choose the filler items with equal probability from the top X% of the most popular items. So they do not use the top one. They do not use the most popular one, but they use the maybe top 100 list. That's why they use it the average over popular items. So another kind of mix, they use the sampling attack. Sampling attack is an attack that does not contain filler items, and yeah, it has been introduced in this. So maybe I will also explain a little bit about the method in chat. So there are many attack detection methods. Okay. So if you learn in the data mining, I think you learn many machine learning approach like K-means, KNN, K-medoing. Or in the clustering, you learn also the hierarchical approach. So we need also to extract the features. So the feature extraction, you can do with many things to understand whether the attackers exist or not exist. Some of them use the probability methods, just calculate the probability, or some of the research they use the classification. They can use the decision tree, they can use the random forest, and etc. Okay. We need to understand the effectiveness. What does it mean by the effectiveness? It is possible metrics to measure the introduced bias. First, we need to understand the robustness. The robustness means the deviation in general accuracy of the algorithm. Stability. Stability means change in the prediction for a target item. So we need to have before and after. In addition, there is also rank matrix. How often does an item appear in the top n list? Before and after. So for this chapter, I will explain only robustness and stability. So I will skip the rank matrix. Robustness. What does it mean by robustness? The first concept of robustness we can see from the deviation from mean agreement. Mean agreement. It means I know that the correct profiles, okay, the correct profiles, this is not the fake profiles. I know all the ratings, so I can calculate the mean. If I know the mean for the correct profiles, then I can say this is the mean agreement. What we need to measure is the rating deviation from mean agreement. What we call this is RDMA. It is intended to identify attackers through examining the profile's average deviation per item, weighted by the inverse of the number of rating for that item. Okay, so this is the formula. The RDMA of a particular user is a sigma from I0 until NU, and then the particular rating will be minus by the average of, this is the mean agreement, divided by the UNR. UNR is the overall number of ratings in the system given to item I. And then we divide with the NU. NU is the number of items the user U rated. Okay, for example, we have user 1, user 2, user 3, user 4, user 5. And then we have item 1 and item 2. So I want to know the RDMA of user 1. What is the RDMA of user 1? We can look at the rating of user 1, which is 4, on item 1, and the rating of user 1 on item 2. And we need to look at the min agreement. Let's say, yeah, this is just to calculate the RDMA. Let's suppose the average is 3.5. This is the min agreement of the item. So, sorry, I need to put a line here. Okay, this is with per. R per I is the average rating of item I. So RIU is the rating given by the user U to item I. Then I need to do the summation. What is this summation? So the rating of IU, this one, minus by the min agreement. The min agreement is here. And then I will divide with the NRI. What is NRI? NRI is the overall number of ratings in the system given to item I. So how many ratings for the item I? Because there is one missing, then we have 1, 2, 3, 4. Okay, so there are 4 number of ratings in the item 1. So I can calculate this one. 4 minus 3.5. What is it? 4 is from the rating, and then 3.5 is the min agreement in this particular item, and we divide with 4 because we have 4 overall number of ratings in the item. And then we will do again with the second item. The second item is again 4. It is the rating here, and then we minus with the min agreement. So this is the min. Maybe is 4 plus 3 plus 1 plus 5. And then we will divide with 4 because there are only 4 number of ratings in the item 2. And then after we do with this summation, we will divide with NU. NU is the number of item user U rated. So we have the, sorry. Why I divide with 5? I think I wrong this one. This is not 5, this is 2. Why I did 5? I'm sorry, this should be 2. Okay, this is the number of item user U rated. So because the user one rate only item 1 and item 2, so it means there are 2. So we will divide with 2. Then we have the value. So the value is 0.125 plus 0.1875. divided by 2. Okay. 5, 6. Okay, this is the value. Okay, I'm sorry. I think I used previous example. There are 5 items. So this is why I divide with 5. Now I simplify with 2 items. Okay, so if we have only 2 items, then this is the rating deviation from the mean agreement. If the deviation is very small, then that's fine. If the deviation is high, then we need to be cautious. Maybe this is an attack. Okay, due to the time constraint, I think I will stop here. I will continue the next section next week.